Now the modern periodic table is based on electronic configuration. See, I have written the first period. Which are the first period elements? Hydrogen. Hydrogen with atomic number 1, configuration 1. Then helium with atomic number 2 and configuration 2. You can see the first orbit is being filled. So in the first period elements, the first orbit can have only 2 electrons. So the first electron for hydrogen in the first orbit and the second electron for helium in the first orbit. So the first orbit is completely filled. So hydrogen with the 1 as the electronic configuration and helium as 2. Now the second period comes. In the second period, the first element is lithium. The second orbit start to fill 2 1. Then beryllium 2 2. The second. 13th group 2 3. 14th group 2 4. So the 1 electron is being added in the last orbit. So here the number of electron increases by 1 from one group to the other. And the second orbit is being filled. So the number of orbits for the second period of element is 2. So in the second period elements they have 2 orbit and the second orbit is progressively filled. Now when you come to third period, see sodium, start with the sodium 2H1. The third orbit is being filled. So they have 3 orbits. Then after beryllium it is magnesium, it is 2 8 2. So 1 electron is being added in the outermost shell and the third orbit is progressively filled. So the third group elements they will have 3 orbits. And the third orbit is being progressively filled. Now the fourth period you see start with the passion. It has 4 orbits. 2, 8, 8, 1. 4 orbit and fourth orbit is being filled. Now when you come here, this is the first group of elements. The first group, lithium is having 2 1, sodium 2H1, potassium 2H1. So they all have 1 electron in the outermost shell. In the second group you see beryllium with the 2 2, magnesium with the 2H2, they have 2 electrons in the outermost shell. So the number of electrons in the outermost shell will give you the group to which it belongs and number of orbits in the configuration will give you the period to which it belongs. See for aluminium it is 2 8 3. So that means it is also having 3 electrons. In the 13th group they have 3 electrons in the outermost shell. Silicon 2 8 4. Phosphorus 2 8 5. Sulfur 2 8 6. So the third period, the third orbit is being progressively filled. So they have 3 orbits. So the number of orbits will give you, the number of orbits in the configuration will give you the number of period to which they belong and the electron in the last groups, the outermost shell, you see here 2. Second group has 2 electrons in the outermost shell. So the number of electrons in the outermost shell will give you the number of group to which it belongs. So if you know the atomic number of an element, you can configure it. For example, I will give an example. Chlorine. The atomic number is 17. The configuration will be 2 8 7. That means it is having 3 orbits. So it belongs to third period. It has 7 electrons in the outermost shell. So it belongs to 17th group. So chlorine, it has atomic number 7. So if you know the atomic number, you can identify the group to which belongs, group and period to which it belongs and its position in the periodic table. So the position of an element in the periodic table is based on electronic configuration. Another example I will tell you, calcium, atomic number 20. The configuration is 2 8 8 2. Here 1 2 3 4. 4 orbits are there. That means it belongs to fourth period. 2 electrons in the outermost shell shows that it is in the second group. So calcium with atomic number 20 belongs to fourth period and second group. Understood? So the position of an electron is based on its electronic configuration, and the number of electrons in the outermost shell will give you the group to which it belongs, and the valency of electron, that also. See, the first group elements all have one electron in the outermost shell, so their valency is 1. The second group elements, they have 2 electrons in the outermost shell, so the valency is 2. Okay, so the valency, this is how the position of an electron in the modern periodic table is based on electronic configuration.